It'd be really useful to hear from you in the chat while I'm introducing myself. So please do say hello and say where you're joining us from, what country or area around the world. So my name is Mark Heslop. I'm the International Maths Subject Partner. So I'm a former teacher. I've been with Pearson coming up for 5 years now. For that, I spent 15 years in the classroom as a maths teacher and head of maths. And before that, I was an engineer. So I spent my time designing and crash testing cars. Why I always like teaching mechanics. Hello, everybody. So I can see we've got Mallorca, Qatar. Right, I'll crack on because this is going to be a packed session. All right. Oh, and from the UK as well. We do have a session for those of you in the UK whose colleagues couldn't maybe join this, we do have a session a repeat of this session at 4 p.m. as well. So let's dive straight in and go for the agenda. Okay, so we're going to be looking, and if you do see me looking left here today, it's because I've got this on 2 screens so I can keep an eye on the chat. I do have a colleague in the background also keeping an eye on the chat, but I'll tend to try and respond to things verbally as we go along. So, got a few notices, a couple of updates for you. We're going to look at foundation tier insights and higher tier insights, and I could talk for hours about things that are the statistics and performance in the examinations, but what I've boiled this down to today is I'd like really to be on every slide there's a question, something that you can go away and use. So there are tons of stuff that are fascinating about why questions perform that they do. I'm more interested about the questions that performed in unexpected ways and the reasons behind it. Those things where we might have just underestimated a little bit of our students' knowledge, the revision, the resources that we're using. So I'm hoping pretty much everything today you can go away and do something with. I'd love to know in the feedback at the end whether you think I've achieved that. Oh, seeing from Cameroon as well. Fantastic. So we're then going to go on to talk about tiering guidance. Very much a hot topic for the international GCSE. So I'm aware for international schools, there's an awful lot of pressure especially from parents to enter children for higher tier. And I'm seeing in the statistics that may not necessarily be the best thing for those students. So higher tier nominally awarded from grades 4 to grade 9 with a backstop of a grade 3. I see a spike in the students achieving a grade 3, and I would suggest if they're getting a 3 on the higher tier, they would probably find the foundation tier more manageable, more accessible, and possibly get a grade 4 or a grade 5. So I've got tiering guidance for you. And then I'll talk about some resources. So just as a bit of a note, and this is for the non-UK centres, so we've launched a modular version of our International GCSE Maths Spec A. Due to Ofqual rules, we can't launch a modular GCSE in the UK. But for those of you who haven't seen it or been on any of the training sessions, there is the main specification page. And I get a lot of questions asked around the world about how can we use the exams? Is this allowed? But before I begin, I thought I'd summarize that. So in terms of exam window entry options, so I've got a lot of schools around the world saying, can I enter both units for the modular GCSE in the summer of year 11? And the answer is yes, absolutely. That has some advantages if you have students who need to resit in the sixth form, such that if they do need to resit, maybe they're trying to push a grade 7 to an 8 or a 9, or 3 to a 4 or a 5, they could resit one paper at a time in a modular system. So I think it has less disruption. The main design of the specification was to do the first unit in the year of 10, the summer of year 10, and the second unit in the summer of year 11. I have some centres around the world saying, can I enter? But I think my students might not be mature enough in year 10, enter the first unit in the autumn of year 11, and then the second unit in the summer of year 11. Totally acceptable. Absolutely fine. You do what's best for your students. Just in terms of those tiering, okay, it does give us some advantages when we get a lot of parental pressure. So there we go, those reset advantages. Tiering options. So you could enter a student in the summer of year 10 for high unit 1. If they have a really bad exam result and you think, okay, this is a foundation tier student, you can enter them in the autumn term for the foundation tier unit. They can't do foundation and higher tier in the same series, but they could do them in separate series. And you could use that result to make an informed choice, conversation with parents about whether to finish off Foundation Unit 2 or Higher Unit 2 in the summer term of Year 11. So I think it allows us to help the parents make decisions that are what's in the student's best interest. Equally, if you've got dedicated foundation tier classes and they do really well in that summer of Year 10 foundation, they could try the higher tier unit in the autumn of Year 11 and then decide whether to finish off Unit 2 of the foundation or higher tier. You cannot cash in, say, foundation tier 1 and higher tier 2. It has to be both foundation or both higher at the end of the course. So that's just to get a few notes out of the way of regular questions I'm getting. So let's dive on into this summer's exam insights. Okay. So like I say, I'm looking at questions where the performance is a little bit odd, a little bit interesting. Something I think, maybe we've not called that correctly. And there are a few common themes that come out. So let's go ahead. So the first question I picked out was question 3, probability question. We've got mark on a probability scale and then make an explanation. And it may not surprise you to know. So if anything I've highlighted in green in here, these were in the top 10 marks for the foundation tier students, or top 10 subparts of a question for the foundation tier students. So students are doing really well on their knowledge of the probability scale. And yet, then suddenly part C, so probability Johan writes for bag C is incorrect. Okay. Foundation tier students are struggling with written explanations. Higher tier students, I'm going to say, have made a real improvement over the past couple of years with their quality of their answers and their ability to engage with those. Just a quick explanation. So if you are looking at and you've got some higher tier students that are genuinely struggling on those explanations, that's potentially an application, an indication that maybe foundation tier might be slightly better for them. Here's the mark scheme. Okay, we are, it's a very basic explanation we're after at this stage. So it has to be 1 or less or equivalent, but it's worthwhile just practicing, especially if you've got students entered in the November series. And that's why I've made sure this feedback session is as close as possible as the start of term, so that if you've got students resitting in November or first entry in November, if you're a Southern Hemisphere school, that we can give you this feedback before then. But that's a type of question that's worthwhile practicing with students. Okay, question 6, same theme again, actually. So work out the value of X, give a reason for your answer. And then we've actually got something a little bit more taxing for students. But again, look at those statistics. Okay, on this question, this part B here, which is a 3 marker, your grade 5 students are getting on average 91% of effectively the marks here. These are percentages. Your part AII, give a reason for your answer, a third of students are getting that mark. So yeah, again, that real indication of that students can actually do some quite challenging things. They just need a bit more practice just coming up with an answer. And in terms of those answers, we're actually after something very basic. And if you see in the mark schemes underlined words here, these are the words that we're going to require in the explanation. So angles around a point add up to 360. So we wouldn't accept angles add up to 360. We need some indication that it's angles around a point. And we don't even have to hit all 3 of those bases. 2 out of the 3 is enough. So it's quite, the examiners are quite generous as long as they can see the intent. But we need to see a little bit more than angles add up to 360. Okay. Let's go on to sequences. I'm going to show you the statistics. So part A. So AII, again, one of the best explain. So this is where students actually did quite well on the explain on this one. Part B is where we had to work out the 12th term in a sequence, but then part C pops up again, explain why 7 isn't, says, Umberto says 7 is a term in the sequence, Umberto is wrong. So it's not like that we can't do all the explanations, but when there's something maybe just a bit more involved or requires recall of, say, a geometric reason, the students who have to do it at foundation level, that's where students are falling down. So not so acceptable. It should be 8, or the sequence is in the 7 times table plus 1. But also it's useful to say we include in the mark schemes things that are coming up in the exams that the examiners see regularly, but are not included. So it might be worthwhile using this kind of question as a lesson starter. Okay, what would you put for this point here, ladies and gentlemen? Okay, this is what the examiners say. How many of you would have got it correct? And then moving on to a slightly different theme here. So what does come up in the examiner's report every year is that international students especially struggle on some of the shape and space, more so with when we involve algebra, but definitely when we involve transformations. Now, the interesting thing that didn't come up in the examiner's report this year, describe fully the single transformation that maps shape A onto shape B. Normally we get on that one that the examiner is saying that students are putting more than one step, more than one transformation. And I don't think that the students think that that's how you should answer the question. I think that they know that they don't know how to say represent a rotation and are just putting anything down in the hope of getting a mark. That didn't come through this year. But I think there's something interesting that comes out of it. So 14A, describe the transformation as opposed to reflect a transformation in a given line. Now, certainly your grade 3 students struggled on that second part, but your 4 and 5s did okay. Your 4 and 5s still struggled, and again, in the bottom 10 marks of the paper, to actually describe a rotation. Well worth revising with your students. So that idea of being able to do a transformation, students are doing okay on it. Even if it's foundation tier struggle, students struggle to put y equals -1 on a set of axes, but are better at that than actually describing a transformation. So those rotations, reflections, well worth engaging with your students ahead of the next series. And there's the mark scheme for you. Just so you can see how we get students to describe that one. So that's kind of a quick summary of foundations here. There was a few other things that came out from the exams. I am spending more time on the higher tier feedback here because we have a lot more interest for higher tier than foundation tier. But just as a quick summary for foundation tier. So the examiners did say, based on their performance on this paper, students should learn formulas so they do not get mixed up, for example, between the area and circumference of a circle. And I'm going to show you a way to do that in a second. Students did struggle with unit conversions, so miles and kilometers, and certainly on unit conversion in terms of time. So knowing that there are 60 minutes and an hour, and be able to convert 9 hours, 36 minutes into 9.6 hours, rather than, as a lot of students do, write 9.36. When drawing lines on a grid, these lines should be labeled with an equation to avoid seeing, e.g., 2 horizontal lines or 2 vertical lines, being a choice of answers and therefore scoring no marks. Learn that angles in a quadrilateral add up to 360 is a common theme across the questions. And become more competent in the use of negative integers in calculations. My question for you is, do you do an equipment check at the start of the examination? Came up less so this year, but has come up in previous years, especially when we ask students to measure an angle or measure a line at foundations here. The examiners know that the students haven't got the right kit because they're actually saying it on the exam paper. They're saying, I couldn't do this because I didn't have a protractor or the shards of something that used to be a protractor. So my question for you is, when your students go into the start of the exam, do you check that they've got the right kit? Now, I wouldn't advise asking students to put their hands up if they're missing kit, because that's quite embarrassing for them. But I can check an entire exam hall of 180 students in about a minute by just saying, right, everyone put your kit on your desk, whiz up and down the rows, quick visual check. Make sure everyone's got kit or hand out kit to students who haven't got it, and then leave the room so it's then over to the exams team. That's perfectly acceptable to do. Do we check that? Do we also check that students are, I should say, I was going to say practice justifications with students is a key point, but do we also check that students are familiar with the formula sheet at the front? Because the examiner said, learn formula so they do not get mixed up. So the foundation formula sheet, although it includes the volume of a cylinder and the circumference of curved surface area of a cylinder, we can teach our foundation tier students to check this and extract that circumference of a circle or volume of a cylinder. And it comes up on these higher tier as well. Students are not checking their formula on the front of the paper. It came up this year and it came up last year. Do you remind your students, even just before the exam, first thing you're going to do, ladies and gentlemen, is open up that front sheet and just refresh what is there. Okay, so on to the higher tier. Okay, some fascinating things that came up from the higher tier. Let's fire up the statistics. I'll come to this comment that I've popped on here in a second. So students can do explanations at the higher tier. So let's go for part B here. That was amongst the best answered questions in the paper. Is it true that B and C is an empty set? So, and give a reason for their answer. So yes, they can do that. Where students are struggling, and I've got a really nice example of this on another Venn diagrams question in a second, is interpreting this notation here. Now, my advice here is that either drawing a quick sketch might help them, but that could be a bit longer. Perhaps it's even just a sketch of even numbers, these three, and a circle labeled multiples of 3. But getting them to actually write out what this means, not even and a multiple of 3, could perhaps frame this better in their minds for when they're trying to extract the correct answer. What I also see in the exam data on this and previous exam series, when you get the complement of a set, A dash, B dash, students are more likely to struggle with that than even on some of this more complicated notation here. So here we go. 63% on part C. Arguably, this is more complicated than this, but students are actually getting lower marks on this one than they are potentially on something more complicated. Less so for your grade 8 and grade 9 students, but certainly as once we start to drop down, students tend to struggle with this kind of notation. And that's an interesting one that was you get the grade 9 students, that was the lowest mark they scored on that question. Okay. There's an example of the mark scheme for you. Okay, I've just got to slide out of order there. Okay, so question 12. Fascinating one. Factorize fully was an interesting one, but then express as a single fraction in its simplest form. So I think students do struggle with, say, non-unitary x squared or y squared questions, more so when the coefficient here, from what I see, is an odd number. But these are the marks that came up in it. So 56% of students got the marks on, the students scored 56% of the marks on A and 55% on B. But B was one of the lowest marking questions for your grade 8 and your grade 9 students. Now, arguably, this should be harder than this. But this is potentially maybe one we just maybe underestimate a little bit for our higher tier students, those top end grade students. And it's worthwhile just keeping an eye on that we're practicing adding together algebraic fractions. I'm going to say specifically where there is an algebraic term, an unknown, in the denominator. Okay, there's the full mark scheme. If you want to have a look at it, you'll get sent copies of these slides. And anything that I'm referring to in here that refers to another document, there's a link within the slide so you can see that. Okay. Oh. Question 14. Right. What I am seeing in the data, we're going to get questions that students struggle on towards the end. We're going to get questions that students do well on at the start. I am still seeing, to a degree, a little bit of a mid-paper dip. Both to a degree, the foundation and the higher tier. And a lot of the questions I pull out on the higher tier are those question 10 to question 20, where I think, theoretically, I would have expected students to do slightly better on that one. Now, I know we all encourage students to go and check their work at the end of a paper. But that's a massive task for students. I think they do better at checking if we gave them something to be a bit more focused on. I think at the start of the paper, students are going great guns, they're getting through the questions, they're maybe starting to get a little bit fatigued in the middle of the paper, losing marks. And then they know the questions at the end are quite hard. So they brace themselves, they double down on their efforts, and actually those questions perform as expected. What I see is a mid-paper dip in some questions. And I think if you're going to advise your students to go and check an area of the paper, so, right, if you've got any time at the end, ladies and gentlemen, spend your time reworking those middle questions where you might have lost some marks that you shouldn't have done. So, yes, there is quite a lot going on in this question. But actually, if they're methodical, they can get through it. And in terms of the marks on this question, the average mark, average student scored 37% of the marks. And again, they're all highlighted red because these were in the bottom 10 subparts on the paper. So even your grade 8 students are only getting 50% of the marks on this one. And your grade 7 students are getting 26% of the marks. I think potentially what students do, well, this is a good one to use as a lesson starter in class. I think students start here and try to work out some link linearly from that. Whereas actually we can school our students to maybe start at the end with Chanda and work up to Bahira and work back to Abel from Bahira. So yes, this was of the more complicated end, but if the students are methodical, they should be able to score the marks. And we just maybe need to get our students to think about, actually, do I need to start with that first piece of information and work on from it? Or actually, is there a better entry point for my modeling in this question? So we start as Chana as an amount. It makes the rest of it quite easy for Bahira. And this one isn't too bad. But just encourage your students to think logically about where they start rather than going from start to end of the information. Okay. There's the full mark scheme. Yes, it is a slightly complicated mark scheme, and I'm not going to spend too much time on that one. But yeah, you can have a look at that in your own time. But on something a little bit more interesting. Okay. Certs. Okay. What is fascinating for me is that a comment came through quite strongly on quite a few of the international A-level pure papers this year, that students are struggling on rationalizing surds, manipulating surds, and recognizing negative and fractional indices, what their relevance to, for instance, surds and rational numbers is. I think if you've got students that want to progress onto international A-level, it's crucial that they understand surds, fractional, and negative indices. So it's one that's well worth practicing. And bearing in mind, this is question 17. Yeah, I think it's worthwhile just checking their understanding on surds before you go on any further with them. So came through as well last year in terms of rationalizing surds. The interesting thing is, from the statistics, certainly from one of the papers last year, is that when a student does realize what they need to do to rationalize, that they do need to multiply by the conjugate of this one, so 3 plus root 5 on top and bottom. Once they've realized they do need to do that, they're then very reliable at picking up the remaining marks, even though there's good opportunities for numerical mistakes in there. But it's the confidence to actually have a go at rationalizing these that seems to put students off. Maybe they think I'm not going to be able to get it in the form A plus root B. But actually, if students begin these questions, the evidence would suggest that actually they're pretty good at finishing it. Check where I am for time 1 second. I'm just going to have a quick look at the chat to make sure that nothing has come through in there. Okay, we'll move on in just 1 second. I'm just going to resize one of the chat windows so I can see where I am. Okay, so on to the next one. Let's go. So a curve has the equation y equals x cubed minus 40x plus 1. Find the coordinates of both points on C at which the gradient is 8. And I'm actually going to compare this in a second with another question. I think I might actually skip forward to that one now. Let's go. Here we go. Right. So here is question 19. Okay, quite a complicated trigonometry question. And to go back to this question here, students, and it's a relatively straightforward differentiation question. They've got to differentiate, they've got to differentiate first of all, and then they've got to set their differential equal to 8 and solve that. So students on average are gaining, even grade 9 students are gaining, sorry, this should be the all students, 41% of the marks on that for all students and 51% of the marks on something that is arguably a lot more complicated. I have seen in the international GCSE students well able to tackle quite complicated trigonometry on other papers as well, and then fall down quite badly on some basic differentiation. And I think it's one that is worthwhile just examining in your schemes of work. How much time do we spend on differentiation? There's nothing too tricky about this one. As long as students have actually differentiated, they're going to pick up a couple of marks on this one. Being able to set it equal to 8 and solve gets them, effectively the 3 remaining marks. Some students rushed at this and tried to square root without realizing that they're actually going to get 2 answers for the gradient, and some didn't actually work out the final y coordinate of these. But the way into that is that differentiation. I'm going to suggest even basic differentiation is a barrier of entry to these questions. Interestingly, from my experience of teaching A-level, teaching differentiating y as a function of x, students cope quite well with. It's when we move on to x as a function of t at A-level that students struggle with. I've kind of seen in the statistics that it's potentially the other way around at international GCSE. I think starting off differentiation, that x is a function of t, and then working out the velocity, and then working out the acceleration, possibly embeds it in a bit more of a context, because I actually see those questions performing slightly better than just a straight differentiate y as a function of x. So maybe it's worth investigating in the teaching when you're introducing differentiation, introducing it in context. Differential of displacement is velocity, differential of velocity is acceleration. Relate that back to the graph and relate that back to gradients before we move on into differentiating y is a function of x. But I am seeing questions that differentiation does underperform, and I'll say again, in comparison to questions such as this one, where students do perform much better. So here we go on this one. So this is those 2 questions again. This is the differentiation. This is question 19 on the trigonometry, and I'm going to fire up the mark scheme on the trigonometry. So we've got to use the sine rule, and there is some evidence that students are not looking at the front of the exam paper. We've got to manipulate the sine rule. We've potentially got to use the cosine rule in here. There is a lot going on in this question compared to that differentiation question. And yet, here we go. That differentiation question came out for most students bar the grade 8s as in the worst 10 performing questions or subparts on the paper. I think actually there's something really positive in here, that even grade 6 students on this question are getting, on average, 50% of the marks. Grade 7 students, 3/4. Grade 8 students, that's where, sorry, these should be all do or more. So these are the grade 9 students are doing really well on this question. And yet, on a basic differentiation, they are not scoring the marks. And I think it's actually quite refreshing to see how well students can do on these kind of questions. So let's go further on. Okay. Paper 2, higher tier. I think this is, in some ways, not a surprising one, but a good one to show your students in class. So change a speed of W meters per second to a speed in kilometers per hour. And the examiners did say that they actually got comments, people writing on an exam day. Did we mean to put a number in here instead of W? No, this was give your answer in its simplest form. This was intended that they should work in generality. I don't think it's a surprise on this one that a lot of students average scored 44% of the marks on this one. But I do think it's one that's worthwhile practicing in class. I think a classic one for students is, if there's 7 days in 1 week, write me down an expression that links weeks and numbers of days. And the classic one is for them to write down 7D equals 1W, rather than the other way around. So I think students just need a bit more exposure to these kind of questions for a bit of practice. Check how I'm doing for time. I'm just going to fire up the chat, see if there's anything in the chat that's come through. Okay. Right. Ali uses a fitness tracker to count the number of steps he walks each day for 7 days. For the first day, his mean number of steps is 11,800. For the first 4 days. For the next 3 days, his mean number of steps was 13,207. Work out the mean number of steps for the 7 days. The examiners did say it was a well-answered question on combined mean with many fully correct responses, but I did actually want to just flag up for you the marks and the questions around it. So here we are with question 12. Now, this is what I mean almost about a mid-paper dip on questions, that actually it's something that's just a bit, where it requires a bit of thought. And suddenly we're seeing, grade 5 students going from 66% on the previous question to 41% on this one. I think this is one worthwhile just exploring with your students in class for this kind of question, because it has come up before. The examiners did say some students, however, did not know where to start and presented a solution that involved adding the two means and dividing by 2, or even dividing the mean by for 4 days by 4, and the mean for 3 days by 3. And those incorrect methods obviously scored no marks. But I think this is a nice one just to explore in class, because I think it reveals an awful lot of misconceptions about how your students think about the mean and what we have to do before we can come up with an overall mean, would be my best advice. Here's the mark scheme for it. Again, you'll get these slides so that you can use this in class. But yeah, I think an interesting one to use as a lesson start. Okay. So, on to question 15. Okay. I've got 2 question parts here. So make G the subject of this, and then we've got solve the inequalities. It's a 4 marker and a 3 marker. And my question for you is if you could throw into the chat, please, which question you think students got a higher proportion of the marks on. Gives me a chance to have a quick sip of tea. Which question you think students got a higher proportion of those overall marks on? 15A. Part A, part B. Part B. I love it when there's a conflict in the chat. It's quite interesting sometimes with this, that once someone's answered for one part, for say B or A, you often get a flurry of responses not wanting to disagree. But it's quite nice to answer quite trick questions. Here's the performance of it. I think this is quite technical. So we've got to, and students overall scored 65% of the marks on this one, and 49% on the solve the inequality. Now I know the tail end of that, solving an inequality, is quite hard, but I would suggest to you what students struggled on is solving a quadratic initially with 3y squared. And I think we do just need to make sure that we're exposing students to that. Let's just see, we've got the full mark scheme here, the factorization of it, the recognizing of the critical values, and then the identifying the actual regions themselves. I think that last part is quite hard. But I actually think the first 2 parts of just effectively solving a quadratic I think what threw people there is the 3y, but in some ways that was slightly, in theory, slightly easier than the previous quadratic that we had, which I think my memory says was 6x squared or 6y squared. That's actually slightly trickier because we've got a number of combinations that we can use for the 6y, 2 and 3. This one, there's only one combination, but I think students are avoiding certainly odd numbered quadratics, and also when it's built into an inequality. As a level of detail here in part A, this one required squaring, multiplying both sides by the denominator, collecting of like terms, and factorizing out for a g. That's a complex question. There's plenty of opportunity to make mistakes in there. So I think it's one to just be careful. And then to go back to, for those higher tier students, we've got a Venn diagram question. I actually quite enjoy these Venn diagram questions. I think they're quite interesting. So 60 students were asked if they would like to attend workshops for knitting, photography, or embroidery. And then we actually have quite a lot of information that we ask students to put on the Venn diagram. These make me scratch my head. That's why I quite enjoy them. There's a nice bit of challenge to them. Okay. And then we have find the probability that this student, so given that a student chose photography, find the probability that the student also chose knitting. Find the number of students that did photography and not knitting, and then find the number of students. I'm not even going to try and interpret that one quickly. I think what's absolutely fascinating on this, when we fire up the statistics, and do bear in mind that we allowed follow-through marks from their diagram, but 16A, students scored 72% of the marks overall. When we start to get into part B, find the probability, that's when it starts to drop off. And this is where in that red area of some of the worst answered questions on the paper. So part B, we've actually got a conditional probability here. So given that the student chose photography, and then we're into numbers of students again. And it just stresses that I find it interesting that students find extracting information from a Venn diagram harder than actually putting the information into the Venn diagram in the first place. So even putting information into that Venn diagram, your grade 6 students, get my cursor back up, scored actually quite well on here. But we need to focus on those written interpretations of what is being asked. The number of students that did photography and didn't knit, I think, is one way to improve what we're doing on this one. I always find it interesting when I kind of internally make an assumption about what I think is a student's going to be finding more difficult than not, when I see something that really sticks out. And this really sticks out, that we're seeing a couple of things in these papers. So that last one where we were rearranging quite complex work, finding better than basic solving of inequalities. And on this question, where putting all this information into a Venn diagram is challenging and time consuming, and then students are actually answering that better, then, and I know these are a little bit technical, but not necessarily highly technical compared to, say, that rearranging a form under a square root. Okay, now I've got a fascinating one for you. Okay, equations of lines. The straight line P has the equation 5y plus 2x equals 7. Find the gradient of the straight line that is perpendicular to P. So we've got a number of elements of challenge going on in here. Firstly, they've got to rearrange the formula. But bearing in mind, we know they're good at that from the question that was 2 questions ago with that square root, where they had to square, multiply by the denominator, gather like terms, factorize, and rearrange. Okay. Okay. 2 marker. Average mark across all of these was 50%. And even your grade 8 students are only scoring really 3/4 of the marks on that one, or an average score of 3/4 of the marks. When you get into your grade 6 students, it's really falling off. And I've actually put on here the comments directly from the examiner's report. Okay. This seemed like a very straightforward question for the grade at which it was targeted. However, we are now of the very strong opinion from the evidence from a great number of students that many do not actually know what the gradient is. We were very surprised that most students seem to think that the gradient is a value of x or an equation 2.5x, 5 over 2x. We're commonly seeing it as the gradient as was an equation with the gradient of 2.5. We would strongly recommend that students are taught that the gradient is a numerical term and not a number with an x attached. For this reason, many students only gained 1 mark because we wanted to see the gradient stated correctly as a numerical value. It actually came back to one of the questions on inequalities before, that students could recognize and plot y equals 1 or x equals -2, but when it came to plotting y equals x plus 1, that was one of the worst performing questions on that particular question. Please just check your schemes of work. How often are we revisiting gradients of lines and equations of lines? So, based on the performance of the paper, students should, and this is kind of a bit of a summary of this and what else the examiner said, learn what is meant by the gradient, be able to differentiate the statistical terms such as mean, median, range, and mean. So there is some evidence students are mixing those up. If an extra piece of paper is used, indicate which of the solutions in the answer is in the answer space, or the additional response is the intended solution. Improve understanding of set notation. Know how to use trigonometric functions correctly and how to label angles correctly. Know how to manipulate speed, distance, and time formulas. It did come through as a point that students are, and I know the examiners say, know the difference between simple and compound interest and how to apply each method. When we're getting compound interest questions, students are just sometimes applying or often applying simple interest. And I don't think that's what they think they should be doing. I think it's that they don't know how to do compound interest. They're potentially fishing for some marks. Okay, and what does come through again this year as well as last year? Be able to use the formula given on the formula sheets. Students are reminded that the formula for the cosine rule and the sine rule are given on the formula sheets, as some students quoted the cosine rule and or the sine rule incorrectly. Now, for the examiners to pass comment on it, that's probably coming up quite a lot more than you think. Now, final comment in here, be able to differentiate, to apply differentiation to a problem, I think is a quick way to fix some of the things that we're doing in class to help our students demonstrate what they know in examinations. And students should be warned that when asked to show their working, must, when asked, show their working or risk gaining no marks despite correct answers. Okay, I hope that was okay. You will get a copy of this. I'm going to just look at some tiering guidance and then we'll look at some resources to support you. So, I spend a lot of time every year. I'm going to explain this in a second. I spend a lot of time every year looking at those crossover questions. So, generally speaking, the last 40 marks on the foundation paper become the first 40 marks on the higher tier paper. And it's one of the steps that the examiners use in terms of awarding grades. But it also gives us insight into how students are doing. Now, if you're doing internal mock examinations this half term, then I would strongly recommend you just have a quick look at what the crossover performance is. And there is something that is always quite interesting. So this is the foundation tier performance and the higher tier performance from paper 1. And we've got the totals of them. So on those crossover questions, the average grade 5 student at foundation tier scored 25.4 marks. And your higher tier student scored 24.19. Now then, this is something that is more often than not true, that foundation tier students cope slightly better on those crossover questions than the higher tier students. Why? Well, they're the rear end of the foundation tier paper. So this is the content that for dedicated foundation tier students, their teachers are practicing and run up to exams constantly with the assumption that they know the stuff at the start of the paper. Whereas for your higher tier students, this is the stuff at the start of the paper, and potentially their teachers are more concentrating on the rear end of the higher tier papers. So we do see I'm just reading Claire's comments. From experience, students transcribe the formula incorrectly from the front of the paper to the page where it is needed. It is not also the case that they didn't know the formula there or how to use them. I wouldn't say I disagree with that one, Claire. I do think there's some evidence that there's some transcription errors going on. But I also think there's an issue that we do see that evidence that students haven't even engaged with that formula sheet on the front of the paper. So yeah, I think it's worthwhile potentially. I don't think it's worthwhile not reminding them off the front of the exam paper was my comment on this one, Claire. So to come back to the crossover questions, how can we use them? So there's all the full data. I'm going to just come to a summary that will give us more of an insight in how to use them. There's the crossover data of paper 2. So you can see, again, grade 5s here, doing slightly better than grade 5s here. So if you're doing a mock paper in this autumn term, it is worthwhile having a look at either foundation or higher tier students, thinking about how they did on those crossover questions. So if you have a grade 5 student, or a student on the foundation tier, arguably, if you put, say, a grade 5 student through a foundation tier paper or a higher tier paper, something that's built into the system is that they should theoretically get the same grade from that one. I think they're going to have a very different exam experience doing it, but they should theoretically get the same grade. But if you have a foundation tier student, and when you look at their crossover marks, they're getting much higher than, say, 50, they're getting in the 60s, might be worthwhile thinking, actually, is this more of a higher tier student? Should I be making sure that we've dotted our I's and crossed our T's in the remaining part of the course to perhaps give this student a chance of attempting the higher tier questions and getting a higher tier grade? Certainly, I think if they're getting this term in the region of these kind of marks on a foundation tier paper, I think it's definitely worth considering because they're not the finished article. They're not as experienced as they would be later on in the course. And likewise, if you've got a student, a higher tier student getting in this range of marks, certainly if they're in this range of marks, it is certainly a case of, well, actually, would that student have a better experience at higher tier, foundation tier, more limited revision, better experience of the questions? Definitely, I think this is the key one. If they're getting 60, 61, they're in the range of what grade 6 students achieved on those questions on the higher tier. And it's then worthwhile thinking, okay, so if they were to go in for a higher tier paper, I'd say how many more marks would they need across the remaining 60 marks on paper 1, 60 marks on paper 2? Probably fewer than you think. So the grade higher boundary was 40 for grade 6, was 40 on paper 1, 43 on paper 2, and overall it was 84. So they're only going to need 20-ish marks across the remaining parts of the 2 papers to actually get a grade 6 overall. And it's then a question of, is that feasible on this remaining content that's going to be in the remaining 60 marks of each of the higher tier papers? Is it then feasible for them to gain another 10 marks in those remaining 60 marks? It's an interesting thought, and maybe that helps you have those more informed conversations with students and parents. Okay, so I'm just going to talk about resources for a second. So I'm aware that for those of you that are international schools that are currently using the linear textbooks for the modular course, it's going up on the website this afternoon. If you check on the modular international GCSE qualifications page, we do have, or will have by the end of this afternoon, a new mapping spreadsheet. And the good news is, okay, so this is where I've been through 900 pages of textbook, question by question for you. And the good news is that 37 out of the 50 chapters across the 2 years are entirely contained within either the Unit 1 modular or the Unit 2 modular. The remaining 13 questions, I've actually gone down to question level detail to just make your teaching as easy as possible on the modular course, whether it's in Unit 1 or in Unit 2. And like I say, that'll be on the modular GCSE maths qualification page at some point, hopefully this afternoon. And then if you're looking for those resources to help potentially boost students up, especially for your higher tier students, those crossover topics with A-level and international A-level skills, rearranging equations, inequalities, solving quadratics. Before I joined the international team, I was working with the team to create effectively a transition resources website. So there is a link to it. And effectively what we took was all those skills that are in the top end of international GCSE that are common to international A-level and A-level, those building blocks, if you like, things like your quadratics, your expressions, your equations, your rationalizing surds. And effectively we took each of those topics from the Key Stage 4, Key Stage 5 textbook and created effectively a video of each of the examples to walk them through how to rationalize surds, things to watch out for when rearranging equations. So we did a video walkthrough example. You can see the kind of topics that we have here: expanding trinomials, factorizing quadratics, simplifying indices, fractional indices, which has come through an international GCSE before. There is a walkthrough video step by step. There's actually about 10 hours of me wittering on with these, but they're all equally applicable to either use them as transition resources between year 11 and year 12, intervention resources in year 12, or actually boost resources in year 11 to just consolidate some of those skills before the students go on to study either the UK or the international A-level. There's a worksheet that goes along with each one. So effectively, these were taken from legacy exam questions, and they also include an example, and then questions for the students. And coming out this week on the International GCSE website for the linear specification, I have a little bit of a treat for you. So I've used, and I know some of you used, question level analysis forms for exams where the students fill in their marks and it gives them a feedback sheet, and it usually gives them a red and a green rating for each question. If it's, say, a 2 marker, it will give them green for 2 marks, amber for 1 mark, and red for no marks. I tried to do something that takes into account the difficulty of the exam question, because if you've got, say, a 2 or 3 marker early on in the paper, students should perform really well on that one compared to 2 or 3 marker at the end of the paper, which is going to be a really hard question. So here's our new QLA. It is fully flexible. So this is the 2024 data. You can take questions out if you've got topics that you haven't yet taught and replace it with data. I'm going to show you where to get that data in a moment. And we've got a red, amber, green rating on each question. Now, interestingly, the red, amber, green rating relates to the performance of how students did on those questions in the live examinations. So here you've got 2 5 markers, the students scoring 2 marks on each of those. This one's a green because it was obviously a harder question, and 2 marks there put the student in the grade range of this grade 7 to 9 students. So it's a bit more tuned feedback compared to just splitting the number of marks into equal boundaries. There is on here an overall summary sheet where you can put a student target in as grade boundaries, and it will actually red, amber, green the student in relation to their targets. I've got arrows in here because I'm well aware teachers get told off for printing in color, because I used to. So it will print off in black and white with the arrows. And there's also a student feedback sheet with the same data. So it will tell them question by question what grade range they were in to give them that good indication by topic, or by question itself, what kind of forms we're actually getting out of them and what they would need to get in that question to score in the kind of grade range that a 7 to 9 student did, a 4 to 6 student did. So I hope that you'll find that useful. And like I say, it's flexible that you can replace questions if you're doing mocks and you're actually changing questions because you haven't quite covered that topic. Now, in terms of the data for that and the data for today, so all the data of the exam performances are actually on the Maths Emporium. If you're signing up to the Maths Emporium, please sign up with an email address that you use for your Edexcel Online account. You must have an Edexcel Online account before you sign up to the Maths Emporium. It's not the same login details, but when someone applies to the Maths Emporium, we check that they have an associated Edexcel Online account, and that's the way that we filter between students trying to apply for access and they don't get through, and teachers applying for access because they can get an Edexcel online account. So it's nice and secure. All the data from today that you can either use to adjust on QLA if you're tweaking questions, or if you just want to look at question performance data, is in this cabinet on the Maths Emporium. Question by question data for you to have a look at out of interest. I've kind of condensed the key points down for you. And then finally, we've got training coming up. So we've got, if you have colleagues or no colleagues around the world that did the regional papers, we've got the equivalent regional paper feedback session next week. We've got understanding assessment and improving outcomes in international A level coming up on the 21st of October. Getting ready to teach international GCSE maths in October as well, and the equivalent course for international A level. I do hope you found that useful. I'm going to hang around for a minute before the end because I'd like to leave a couple of minutes at the end for Q&A. If you've got any questions and you need us to get in contact with you, please just put it on the feedback form if you've got any further questions for us. And I would love to know if you found that session useful or not, and if it kind of hit that objective of having, when a question's up on the board, trying to hit that base of, can people take something away from this slide and use it in their lessons to help improve the math knowledge and the outcomes for their students. So thank you very much for joining us, and I do hope it's been useful. Thanks, everybody. And if you are from the UK and maybe you're on your lunch or you've joined this, there is a repeat session at the end of the day, more so aimed at the UK schools. We put one of this time for schools that are ahead of us in terms of time zones. Thanks, everybody.